And good morning, everybody. Here are your notes and examples for IXL.com. This is going to be in the Algebra 1 section, AA.7. It's going to be on factor by grouping. So we're going to be breaking things up into separate groups and factoring each group. And you want to use this factoring technique if you have a polynomial with 4 terms. So if you have a polynomial with 4 terms, that should kind of raise a red flag that you could try factor by grouping. So if you see 4 terms, then you want to try using the grouping technique. So let's go ahead and just get right into some examples. So here is our first example from IXL.com. So notice on this one we have 4 terms. So a term is separated by addition or subtraction. So 1, 2, 3, 4. So we have 4 terms. And since we have 4 terms, we're going to try factoring this by grouping. So by grouping, you want to look at the 4 terms, but you want to break them up into groups. So if you look at the first 2, we'll call this a group. So if we just focus on those first 2 terms, what do they have for a greatest common factor? They have a 2 in common, so you could factor a 2 out. And then for the variables, they have an f to the third and they have an f to the second. So they have f times f in common, so we can factor out a greatest common factor of f squared. And if we do that, let's clean that up a little bit. So 2f squared gets factored out. So what would have to be left behind if you take off the common 2? So we're taking off the common 2's and we're taking off the common f squared. So what's left behind? You would need an f, because if you were to multiply the 2f squared back in, you would get your 2f cubed back, and then you're going to have a minus 1. And then at this step, I would double check and make sure this makes sense. So if you were to think about distributing this back in, your 2f squared times the f gets you your first original term back, and your 2f squared times the negative 1 would get you your second term back. So you want to make sure that the multiplication is making sense to kind of check your work as you go. So we have the first group factored. Then we want to look at the second group, so the last 2. So what's common between those last 2 terms? In this one, you could either factor off a 9 or a negative 9. You need to watch out for the signs on this, and I'll show you in just a second. So let's just factor off a negative 9. And if we do, what's going to be left behind? It's going to have to be an f here, so we get negative 9 times f is negative 9f. And then we're going to need a negative 1 here, because a negative 9 times a negative 9 makes the positive, or negative 9 times a negative 1 makes the positive 9 on the end. And the reason I knew that I was going to need to factor off a negative 9, not a positive 9, is because in order for factor by grouping to work, the key to it working is that what's left behind in the parentheses has to be identical. So if I had just factored off a positive 9, then what would have been left behind? We would have said this would have been a negative f, because 9 times the negative f is the negative 9f, and it would have been a positive 1. And notice that this does not match the other set of parentheses that was left behind. So in order for factor by grouping to work, you have to be left with the same identical common factor in parentheses. So sometimes you need to factor off a negative or a positive. And once we have this, one of our factors is going to be the f minus 1. So f minus 1 is one of the factors. And what we're essentially saying here is that the value of f minus 1, which shows up twice, has to be multiplied against this value, the 2f squared, and it has to be multiplied against this value, the negative 9. So these 2 values are going to be your other factor. So it's going to be a 2f squared and a minus 9. And like all factoring problems, I would check it. So to check it, you can just multiply it back together. So if you went through and distributed everything back together, your 2f squared times your f is going to get you 2f cubed. And your 2f squared times a negative 1 is negative 2f squared. And your negative 9 times f is negative 9f. And your negative 9 times a negative 1, negative times a negative is a positive, so that's going to get you positive 9, and that is what the original standard form was. So this would be the factored form. So this is going to go into the answer box. So again, the big idea, if you have 4 terms, you want to try factor by grouping. You want to factor off the greatest common factors from each group, and in order for it to work, in order for it to be factorable, you do have to have the same values left behind in both parentheses. So let's try another one. So here's our next one. So if we look at the first group, what's common between those first 2 terms? They have a 5 in common. And they also have a z squared in common. So if I factor a 5 and a z squared off of those first 2 terms, what's left behind on the first term? You would need a 2, because 5 times 2 gets you your 10 back, and you would need a z, because z squared times another z would be your z to the 3rd, plus what's left behind here. You factored pretty much everything off, so you're just left with a 1 here. So 5z squared times the 1 would get your 5z squared back if you multiplied that back together. And then you want to look at your next group. So what's common between the 16z and the 8? We know it's going to be an 8, and you're going to either factor off an 8 or a negative 8. Let's factor off a 8. Let's try positive 8. And what's going to be left behind? That's going to be a 2 and a z, because the 8 times the 2z would get you your 16z, and then plus 1. And again, the trick is that these two always have to be identical. So if they're not working out to be identical, then either you're doing something wrong, or possibly it's not factorable by using this technique, factor by grouping. So I always just kind of put in the group that I need to be left behind, and then I just check it. So 8 times 2z is your 16z, and 8 times the 1 is the 8. So this looks like it's working out okay. So one of the factors is what's in parentheses, the 2z plus 1. And then the other parentheses is made up out of these 2 factors that were factored off. So one of them is 5z squared, and the other one is positive 8. So if you were to distribute these 2 binomials together, multiply them back together, then you're going to produce your original form. So here are your factors. So that's going to go in the answer box. And again, I would always, encourage you to double check it. So if you remultiply it real quick, 5z squared times that 2z, that should get you your 10z to the 3rd, and your 5z squared times the 1 would just be 5z squared. And then your 8 times the 2z would be your 16z. And then your 8 times your 1 would be 8. So that checks out. That is what the original problem was. So these would be your factors. And let's move on to another one. So this one, let's look at the first two terms. So what's common? Looks like you have a 5 and an r squared. So what's left behind on the first term? You would need an r here because 5r squared times r is the 5r cubed. Plus, you would need a 4 because 4 times 5 makes it 20. And then you already have the r squared. So if you were to multiply this back together and check it, 5r squared times r is 5r cubed. 5r squared times the 4 is the 20r squared. And let's look at the second group. So in the second group, you either have a 4 or a negative 4 that could be factored off. And the trick is, we know the parentheses need to match. And notice on the first parentheses, you have a plus sign. But notice on this, you have a minus sign. So the trick to knowing whether you factor off a positive or a negative is to see if you're going to need a sign change or not. So this is a plus, but right here we have a minus. So we're going to need to factor off a negative 4. So let's factor off a negative 4. And if you don't know just by looking at it, just try one and then remultiply it and see if it works. And then if it's not working, switch the sign. So we know we need an r plus 4 to be left behind in order for this to work. And then just check the multiplying and see if it makes sense. So negative 4 times the r is the negative 4r, and negative 4 times the positive 4 is the negative 16. So that this is checking out. This is working out the way we need it to. So negative 4 being factored off was the right choice. And then what are your two factors? One of them is the r plus 4, since that's the common one. So there's the common factor, r plus 4. And what makes up the other factor? That would be these two values here make up the other factor. So it's going to be 5r squared minus 4. So 5r squared minus 4 and r plus 4, that should be your two factors that go into the answer box. And here's another one. So again, look at the first two terms to make a group. So an x squared can be factored off. And what's left behind? We need an x, because x squared times x is x to the third. And then we need a 5, because x squared times the 5 is the 5x squared. And then if we look at the second group, we can factor off a 3. And again, we know in order for this to work, x plus 5 has to be left behind. I just usually put in what I need, and then I check it and see if it works. So in order for this to work, we need a x plus 5 and an x plus 5. So factor a 3 off and then check. 3 times x is definitely your 3x, and 3 times the 5 is the 15, so that checks out. So one of the factors is x plus 5, and then the other factor would be made up out of the x squared and the positive 3. So these two are making up the second factor. So there's your two factors for this one. And here's an example of a more advanced one. This one we have a couple things going on. We have a greatest common factor between all four terms. So if you kind of scan through and look through all four terms first before you get started, you'll notice that every term has a p in it. And the greatest number of p's they have in common is a p squared. So you want to factor the greatest common factor off first. So if there's ever something common between all four terms, factor it off first. So we're going to factor off a p squared. And then what's left behind on each of the four terms? So on the first term, you're going to be left with a 2p squared, because the p squared multiplied by the 2p squared would be your 2p to the fourth. And then on the next one, you're going to have a plus 2p. And then on the next one, you are going to have a, looks like a 4, p to the third. And then on the last one, you're going to have a plus 1. So that would be factoring off a greatest common factor. And what you're left behind with, you still have 4 terms left behind in parentheses, so now we're going to try to do factor by grouping on this. Sometimes when you're doing factor by grouping, the order of the terms matters, and it's often best if you can put it in descending order, where the powers are going from highest to lowest. So notice this one is not really in descending order because we have a 4p to the third here. So this p to the second that we factored out, that's going to be one of the factors, and we're just kind of focused on these 4 terms. So let's rewrite the 4 terms. So we're going to go 4p to the third plus 2p to the second plus 2p plus 1. And this will get it in descending order, where you have your power of 3, and then you have a power of 2, and then this one would technically be a power of 1, and then you have your constant. And this usually works out a lot better as far as factor by grouping, as far as getting everything in the right place. And now let's go ahead and try factor by grouping. So let's look at these first 2 terms. We have a 4p to the third and a 2p to the second, so we can factor off a 2, and then also a p squared. And what's left behind, you're going to need a 2 to get your 4 back, and a p to get the p to the third back. Everything got factored off on that second term, so we need a plus 1. And then if we look at our second group, there's really nothing common except for a factor of 1, so we can factor a 1 off. And you're going to be left with a 2p plus 1. So one of your factors is the 2p plus 1. The other factor is made up out of what we factored off, so another 2p plus 1. So you just ended up with repeat factors here, which is fine. So there's your 2 factors, and then we can't forget about the original factor that we factored off at the beginning. So the p squared is an original factor that was factored off at the beginning of the problem. So you basically end up with 3 factors for this problem. So the p squared we factored off, and then your other 2 factors, and that's going to go into the answer box. So this is a little bit more of a more advanced problem, but still we're using factor by grouping. After we factor off that greatest common factor first, we then have 4 terms left behind, and we use factor by grouping on those 4 terms. And let's try another one. So again, you want to scan through all 4 terms and see if there's anything common. So if we look through all 4 of these terms, it looks like we're going to have some t's in common all the way through. So we could factor off a t squared. And if we do, what's left behind on that first term, we're going to have a 6 and a t, because t squared times t is the t to the third, and then you have another variable here, so it's going to be variable u, minus 9 and a t. So t squared times t is going to get you the t cubed, and then you have the 9. And then on the next one, the t squared came all the way off, so you're just left with a 2u. And then again, the t squared got factored off this one, so it's going to be a minus 3. So that would be factoring that common t all the way out of the problem. So all these common t's, t squared, were factored off, and now we're left with something in parentheses that is 4 terms, and we can try factor by grouping. So if we look at the first group, then what's common between these 2 terms? It looks like a 3 is common between the 6 and the 9, and then you have a t, so let's factor off a 3 and a t. And what would be left behind? You would need a 2 to get the 6 back, and then a u. So if I multiplied those two back together, you get your 6t times u back. And then you would need a minus 3. 3 times negative 3 is a negative 9, and then you have the t. And then if we look at the second group, there really isn't anything common between a 2 and a 3 except for a factor of 1. So we'll factor a 1 off. And you're going to be left with a 2u minus 3. So one of your factors is what's in parentheses, the 2u minus 3. And the other factor is the 3t and the positive 1. And then don't forget about the first factor that we factored off at the very beginning. So you also have the t squared. So those are going to be your 3 factors. And that should be about it. Those are your examples for factor by grouping. So if you have 4 terms, you want to try factor by grouping. Sometimes the order does matter. So if something, when you get into the more advanced problems, if something is not working out the way it should, you want to make sure that you factored off a greatest common factor first, if you happen to have one. And then also sometimes you need to change the order of your terms if it is not factoring the way it should be factoring. And that is going to be it. So I'm going to let you go. Bye. Thank you.